Oh, that was my job.
That's all right. I've done it for you. I can at least do something.
Okay.
And Andrew Perry, yes, all the sessions should be recorded. Free. As long as the others remember to hit the record button as well, but I'm sure they do.
Yeah, the trick is remembering to go and watch the things you're interested in. Too many things going on.
Yeah, that was a good thing about the expo, isn't it? Everything you could dip in and out.
Is anyone else getting
Someone's got an awful tone coming through.
Yeah.
Is that your new headphones, Michael?
I hope not, because it's going to drive you all crazy, along with me.
It's gone now, I think.
It's gone now, so it's probably
Yeah.
not me. Yeah. Okay, so I think we've probably got enough people. We can kick off. I was hoping that with a smaller group, we could make this a bit more interactive. I don't really want to spend the next hour talking, but I have a bunch of examples to walk through, and there's also some exercises that you can do yourself, either well, in parallel or after the session or whenever you wish. And so I'll kick off by popping those up and share my screen. And let's see, just so I can see people. And actually, I'll make that go away. I'll start off on this with this GitHub project. This is the work through yourself, let's build exercise. You see the GitHub URL here. So basically what we have here is some little Vue.js project. So if you know a bit of JavaScript, it should be enough to get you going. It should scaffold you along. And the trick is to click on the Edit on Code Sandbox button, and it'll take you to a page where you'll be able to see the running code eventually. And with knowledge of the Fire API, work through, so the term demo.view page is what you want. And with knowledge of the Fire API, you should be able to fill out each of the bits of code that are tagged with fix me, working from top to bottom, to incrementally get each part of this this simple or not so simple website working and exercising different parts of the Fire API. We have it pointing at our Siro public sandbox, which is where I have some sample resources. And I think there should be instructions on what they should look like that in the, I thought in the README. But actually on reflection, I think they're not there. you'll have to go and find appropriate code systems and value sets to make it work. It doesn't really matter what you use there, but basically there's a series of steps to do searching and looking up and translating. I'm going to work through some demos, look at what's going on under the hood and behind the scenes, which is sort of a more in-depth version of for the code, kind of a live demo. And then given enough time, we may be able to come back to this and I can work through some of the steps myself. So this is going to be a fairly technical session. So if you're feeling like that's off-putting, then by all means go to one of the other sessions. I will not be offended. I'll put a plug in for Charles's session because I think the ECL stuff he's going to be showing is extremely cool. So if you're doing anything with SNOMED, the ECL stuff is really useful stuff to know.
Michael, before you dive straight into it, can I just check if there's anyone in this session that's got some specific questions for Tracey, Becca, about their implementation at the more practical level before you deep dive into the super technical level? Looks like we're okay, so that's good. Go for it, Michael.
We're okay. Okay, so we're not gonna go straight into the deep technical stuff. I'm hoping that I can ease our way in with the front end demonstrations first, and then we can look under the hood to see what's going on. So we have here a number of examples, very, very simple examples of just hooking up some user interface to different parts of the FHIR terminology API. The one I'm starting with, and this is really intended to be the focus of this session, is working with the value set expand operation and the filter parameter. So this is a simple type ahead widget where we can search for SNOMED codes. And so we've seen a little bit of this already. So I can search here for something like acute appendicitis and get a set of matches, select one of the codes, and under the hood, this is the information that was available about that code and that could be drawn upon both to build the interface, but also to populate appropriate parts of a clinical record. In this case, we're using a SNOMED implicit value set. So this is the one that's being used under the hood. But all this code is available if you click on these links. It'll take you to, again, a little code sandbox. You can fiddle with it to your heart's content, save your own versions. Don't worry, you won't muck up anybody else's version. It'll be your own copy, and have an explore about how things work. So that's sort of a common example, and we may want to. And I'll walk through some of the other things that are done here, because of course not every use of value sets needs to have a search field. If you have a small value set, then you may just have a pick list. So here, this is pre-populated with the expansion of the value set. So this is a laterality value set, or you may have something you can sort of directly access, or that you may have radio buttons or what have you. So again, you could dynamically discover the size of the value set and choose the appropriate user interface element to use based on how big the value set is, or if you use prior knowledge to make that selection. And that's the sort of thing that you see happening, for example, in a FHIR questionnaire, where upfront you're making decisions about what type of presentation element to use for different selection options. Charles is going to be showing some fancy ECL, but here we have an example that it's a very, very simplified example of expansion with ECL. So I have here just a list of ECL expressions. So this first one here is just talking about getting the members of this reference set. This is the actual syntax of the ECL expression. And when I click this button, it will do an expand call like this. So it's actually sending this expand with the URL being this ugly looking thing. The reason it's ugly is because it's percent encoded. So because you can have special characters in this value here that might confuse the REST calls, so question marks and ampersands and so forth, they need to be escaped when a URL is used as a value of a parameter. So that's why we're getting all these percent things happening in here. And then we're asking for the first 20 members of this value set when it's expanded. And here you can see there were 6,000 things in the value set, and there's the first 20, and there's the actual result that came back. So there's some metadata about the value set, the actual expansion, and this is what I showed earlier in the follow the Albert code. Exactly this kind of thing coming back. You'll see that there's this parameter section is actually providing feedback on information that was used to compute the expansion. So it's showing you which version of SNOMED was used. So this particular edition, again, percent encoded. So this is the Australian edition of SNOMED, and this version of that Australian edition. And this was the display language parameter that was inferred. So I was looking for Australian English, then UK English, plain English, US English, so with different preferences. So it's been picked up out of the headers from the browser, I presume would have supplied that, and just asking for the first 20 results. And so you can sort of play around here, select different ECL expressions and see what the result is from the different expansions and what the requests look like. Or you might want to just edit them and see what happens. So here we just got a single match. And again, all the code for this you can see by clicking the plunker links and going off and finding, seeing the results. And there's other examples here, batching operations and translate as well. But I'm not gonna focus on that now. So what I will do though is just drill in on this first one, and we'll have a look at the code that's just doing this type ahead. So this type ahead search. So I'll have a look at the plunker. Bring it up, and this was actually written a little while ago, so it's using some older libraries, and you can even see some remnants. You can see the age of this example. It's referencing SG3 rather than R4. It's using AngularJS and Bootstrap. The main reason for that is actually that the Bootstrap UI has a really nice, easy to use type ahead widget. And so all the behavior that you're seeing here is largely provided by the library that gives us this dropped into an input field. I'll just draw your attention to a couple of things in the HTML here. Autocomplete off, autocorrect off, auto-capitalization off, spell check false. If you don't turn all of those things off, then you get really annoying behavior where the browser tries to, you know, as you type in word prefixes, it tries to autocomplete them itself or spell correct them itself. And so you think you've typed in a word prefix and then suddenly it gets changed into something else behind your back. So for these sorts of input fields, you really want to pay attention to turning all those things off. This ng model is where the result of the selection is. So when I select a code after typing ahead, the value will be stored in this result variable. The rendering of the results comes from this custom template, and this is the value that we're going to produce. But this is the core of what's going on, is this type ahead where we're looking at the concepts that come back from the expansion of this value set. And this sort of concepts function is what's defined over in the Angular. And here it takes the term. This is what we've typed in. The value set to expand, and optionally an endpoint. So we have a default endpoint, we have a default value set, so they're just set here. You see the age here, it's even using an STU3, our STU3 sandbox as the default. And then here's the guts of what's actually happening. So we're doing a GET request to our Terminology Server endpoint on the value set resource with the expand operation. And we're providing a set of parameters. We're providing the URL parameter, which gives us the value set of interest, the filter parameter, which is the text we typed in, which was passed into our function. We want the first 10 results. We've asked for the designations to come back as well. So we get this, so let's include designations true. And we've said redundantly actually here that we want the result to come back as JSON. Now, Onto Server happens to default to JSON rather than XML, but just to be clear about it, we've specified we really do want JSON to come back. And then when this returns, our callback runs and our response comes in here. We navigate inside that and we get expansion contains. Or if there are no matches, so this expansion contains is empty, then what we're returning is a list containing an object which just has the display and the term we searched for. So this means that if I search for, I don't know, car crash with dog, which is doesn't have a match in SNOMED, I can still select that. And so it kind of gives a way of falling back to free text when there are no matches for codes. Whether you do that or not will depend on the user experience and the clinical requirements, whether or not it's suitable to allow a non-coded value. But if you're doing, say, a codable concept where this is a permitted approach, then this would be a way of supporting that in a seamless manner. So I wouldn't require you to either select a code or enter some free text.
Michael, so just a question for me on that. So that's really interesting. My kids have decided to have a row while I decided to start asking you a question. Close the door, sorry. Yeah, so one of the things that we were grappling with when we first looked at that outpatient continuation sheet is what happens if the user can't find what it is they want to write in there, because the last thing you want to do is obstruct the clinician from writing what they need to as part of the care record just because SNOMED doesn't recognise it. So we sort of toyed with, well, is it up to the application to actually stop using the API and just revert to allowing the user to write free text? So this is really helpful. This is sort of picking up that scenario, isn't it, this use case?
Yes, exactly. And you can even, it provides a pathway also if there's some error. So maybe there's the network's gone down between the user interface and the terminology server. So you're not getting any response at all, but you still want to be able to record the data. You don't want to interrupt the
that's really helpful, because in our pilot, when our onto server has been down, the form won't even load in the application without it.
Yeah, so I think that's really important to stress is that, as you said earlier in your presentation, that it's more than just you drop in the terminology server. You have to work through all these details of what does the user interface actually look like? What are the requirements? How do you deal with failures, transient errors, all the corner cases that are going to come up?
Michael, can I ask a question?
Of course.
How would you handle then? So where you've got now, the user can't find a SNOMED entry, so you're going to have to resort to storing that free text. Would you then look at that later on, or have some form of monitoring to say, well, actually, it's a term that needs to be added to SNOMED, or if they'd have entered it in this way, they could have found it? Have you come across anything like that?
Yeah, so we have actually. So over in Western Australia, the health department there has their own. They've implemented their own discharge summary product, and so they have full control over the user interface. And it was their process and experience of adopting SNOMED. And one of the things that they were concerned about was exactly this. What about gaps in SNOMED that actually need to be filled? And so they did a couple of things, and maybe I'll just, since it's come up, I'll show this exemplar. So this is down the bottom of the list here. They implemented a system where they didn't want people to be able to easily just type in free text.
Yes.
So, and they also went for this sort of two-field type approach. So you could either put a code in, or you could put in the free text. So what they did is they said, well, the free text field is disabled to begin with. It's not until you've searched and failed to find something that you're then able to put in free text. So you start searching for something, you get your appendicitis, everything's good, and on you go. You haven't found what you're looking for. You haven't got a match. Now this free text field is enabled, and so I can put in what I want. And what they did was they computed a distance between the two fields. And if the thing you searched for wasn't close enough to what you entered, then it would reject. So what they wanted to do was stop people from doing things like just typing in some rubbish, so that they could then get this field enabled and then put in the appendicitis and work around things. So that you see this is now disabled. the other thing they did was when people did put in free text, they monitored that and they looked at whether or not those things were good or not, and they would go back to clinicians and follow up. But also they would use it to fill in gaps and also look for like missing synonyms or missing acronyms, all sorts of things like that. So not just missing concepts, but things that were perhaps impacting on people's ability to search and find what they wanted to enter.
That's really interesting to see that.
Yeah, so that they actually did that and put that in production, and they have amazing data quality and compliance out of that. And that need to monitor, of course, started off high, and then the number of new things that they had to add tailed off quite quickly, I think.
I think it was a really good example, Michael, for where with doing it, they built a lot of trust and buy-in with the clinicians. So the clinicians really started to learn that SNOMED was actually a very useful interface terminology and that you could be really responsive. And so I think that constantly monitoring around where there was still free text and feeding back, and that was one of the things that supporting that implementation led the National Clinical Terminology Service in Australia to go to monthly SNOMED releases. And we were able to respond really well to the clinicians, build that trust with the clinicians. And I think in the first 6 months of going live, the clinicians were complaining that they couldn't get the terms that they wanted. So they were able to actually investigate that and find that 98.5% of the time, they always got a term that they wanted. It was kind of that 1.5% irritating them. Half of those were actually misspellings and different acronyms. So they were able to build that into the search. And then there was new content that needed to go up as a request to the terminology service. But that's now been this is its 9th year of being live. So they've got, now for all of their major teaching hospitals across WA and into the regional centres, they now have excellent coded quality data for their discharge summaries that's feeding into their ongoing reporting processes.
It also demonstrates the importance of feedback, closing the feedback loop, doesn't it?
Yeah, and I think that's really where it got the buy-in from the clinicians, because they could see that they were able to inform, the system was responsive, they got the content that they needed, and it built a lot of trust in both the applications locally, but also trust with the National Terminology Service itself.
So how many concepts got added through this process?
I think in the first 6 months of operation, only a couple of hundred, and then it died off because there really wasn't that big a gap. It was just there were some common presentations to ED that were missing that was required for the context. But while it seemed to the clinicians irritating, when it actually came through and they had a user group and you could actually demonstrate that it was more around misspellings or acronym issues, I think it was really only a few hundred, and now it trickles down where I don't think WA puts many requests through at all. And that was quite similar, I think, to Michael, your experience with the Queensland implementation. To support their go live, there was a few hundred concepts that were required as they went through with surgical, but then it really dies down over time. So it's being able to be responsive in the early days and demonstrate to clinicians and understand why they're not getting what they want from a search. And being able to demonstrate that back to the clinicians and get on top of that really, really quickly, rather than kind of letting it build up that SNOMED's not useful, it doesn't have the content that they need.
Yes, because the other experience kind of where someone that has done this and haven't seen their interface, and your interface is kind of pretty slick at kind of making people try, which actually is I think is a great educational tool. But Kaiser Permanente in the US have a policy of sort of allowing clinicians to kind of use their own language, and they have a whole kind of terminology section which is probably bigger than the whole of the UK Terminology Centre, to kind of actually get that content added to to their extension of SNOMED, and it becomes a massive task. So.
No, yeah, I can tell you that there's one guy who actually manages this and manages the application itself over there. And it did not, yes, it drove some of those initial requests and we definitely worked back with them, but it wasn't about creating a whole bunch of new content. And if it was about those acronyms and those search terms, they just went into the search criteria to drive the system. It did not come back into the SNOMED release because there was a real push around the preferred terms going into the record. So even though they could search, it was absolutely the preferred term that goes into the record itself, not all of their misspellings and all of their acronyms and all of their synonyms. So, and I think that's where it's really improved the data quality and hasn't created that huge maintenance burden, either regionally in WA or nationally back at the National Release Centre.
Yeah, but it looks like a very nice compromise at pushing up that data quality and sort of conformance, even if doctors don't like to conform.
Yeah. So the other thing that's going on here is that we're taking when we do get back a set of matches, we're processing them to extract the information we want. So we asked for designations to come back. The reason I did that was so that I could get the fully specified name. And so that's what this code is doing. It's iterating over the designations, looking for the designation use equal to this code, which is the fully specified name code. And then extracting out the semantic tag. So the last bracketed thing in the fully specified name is the semantic tag, and then squirreling that away in this tag field. So that pops out at the end, and then it's then available for the user interface code to then build this rendering here where the preferred term is shown and the semantic tag is put on the end. And the reason I've done that here is because this is a very, very broad value set that spans hierarchies. If you're within a single hierarchy, then the semantic tag is going to be the same, and you don't need to do that. But when it's something like, if you search for cataract, you want to know you're choosing the disorder rather than the morphology, or you're searching for something like influenza, you want to be able to choose the disorder and not something else that looks similar but is in fact an organism or something other that's not appropriate. That's a very sort of simple example. This is the SNOMED interface that I wanted to get to, which actually demonstrates the use in a EMR-like view of different ways, all the different ways we talked about of interacting with value sets and gathering data. So we see here, we have a drop-down. It's populated by the expansion of the value set. We've got the different options that we could choose here. We have a smoking status field. We haven't set the smoking status, so we can't say what type of smoker we have. So we've got some validation going on across fields. If I'm a lifetime non-smoker, well, then I can't have a smoker type. But if I'm a current or former smoker, then those fields are enabled. So we can do validation there. That's just simple. Have you set an appropriate value or not? Kind of validation in the interface. I'll show some more sophisticated validation here in the encounter tab. So this is really just the same thing we had before. We've got a reason for presentation. These little info boxes actually tell you something about what's going on under the hood. So this value set is a very broad value set. It's allowing you to choose findings, procedures, situations, or events, because your reason for presentation could be any of those sorts of things. So it's a very broad set of possibilities. Diagnosis, however, is narrowed down to something smaller, although here it's still pretty broad. And in fact, there is a whole lot of stuff under clinical finding that's not appropriate for diagnosis. Not just the things that are not diagnoses, but are symptoms, but there are little patient-reported subsections and so forth, and navigational concepts that are also not suited. So this is works for a demo, but you wouldn't use something that broad in a clinical system.
Michael, sorry, I don't see the hand up functionality like Teams, so sorry if I'm being rude.
No.
Throwing in with a question. Have you come across any implementation scenarios where users use acronyms, or do is that a complete, so our CCIO, our medical director, Ridian, he's a urological surgeon, and he'll say things like, oh, but I can't find CT cub, because that's how he would handball it. He would just use the widely understood acronym that they use in their field. Now we're trying to say, well, you just shouldn't do that, but have you ever come across where there are those scenarios? How do you manage those?
Yes, so SNOMED actually comes with a whole lot of synonyms that include acronyms. So you see, for example, T1DM. So this is SNOMED AU. So I know SNOMED UK different and actually doesn't have this acronym in it. But no, I've searched here for T1DM, and that's an acronym for type 1 diabetes. And so I search for that. I get the matches or the possible matches, and then I choose the appropriate match.
That's interesting.
And so Onto Server knows about some conventions that SNOMED uses for acronyms, and so it sort of auto detects, because they're not explicitly called out. So it auto detects and adjusts its ranking, because it recognizes that this is actually an acronym. But not all the concepts in SNOMED do have acronyms associated with them that might be, because often sometimes they're local to a particular facility or even a specialty. So there are ways around that. One option is to define a code system supplement and add in additional synonyms via the code system supplement. And then you can get your value set to say, also use this code system supplement when you're doing the expansion. And Onto Server will then have those additional synonyms available as part of its search process. So it's still, it comes down to defaulting to the preferred term as the thing that you would store, but the thing you can search on is the thing that the clinician wants to type quickly to get to what they want.
That's helpful, but the prerequisite of that being that it would have to be a known synonym within your SNOMED CT version.
Yes.
Okay. That's helpful.
Now, I guess the other thing is, because it's doing word prefix any order, lots of acronyms can be found by just doing space separated characters, because they're all word prefix. But that's kind of that's a bit of a hack and not something that people are likely to want to do, except in an extreme desperation. The best way is to, if there are common acronyms, is to support it that way through the code system supplement approach.
Or we could be a bit strict and just say, come on, you know what the real terms are, just use those.
Yeah, and really a lot of them, if you're just doing a couple of characters from each word, it's almost as quick as the acronym.
Yeah,
and possibly
absolutely.
even quicker.
And that's the thing, isn't it? It's about trying to get over that new way of searching,
Yes.
you know, rather than how you would have done it previously. You mentioned about that defining a code system supplement, but that would still be based on any synonyms that are already in SNOMED.
No, you can.
I was going to say you can create your own
synonyms.
right?
Yes.
Which you can that would have been mapped to the preferred term or what you're associating that extra synonym to.
Well, you say here, this code that is in the code system.
Yeah.
I'm going to supplement it with this additional designation, which is the synonym. Yeah.
Yeah.
So it lets you put extra synonyms or translations. That's the primary reason for supplements, but it also.
I bet they can grow and grow, though, is my concern.
Yes,
Isn't
and
it,
someone
you
has
know?
to maintain them, and yeah, all of that.
We might keep that one quiet, Beck.
Yeah.
Michael,
Yeah, no, I was, yeah, it was more whether it was just unique to us or whether that's something other people have faced, I guess, is certainly not something that we'd want to suggest or try and maintain.
Yeah, I think pushing back on it is probably the best first step. But if you're forced into it, there are mechanisms to cope with it.
So yes, because the read codes used to have acronyms built in as keywords, so you could actually do a keyword search, and it allowed you to do these things. And a lot of the GP system suppliers added their own. But Michael, did I hear you say there was some part of SNOMED that had these built in, or was it purely as a supplement?
No, SNOMED has I can even show it here. So if I do, we have a look at. Actually, I don't know if I think I'm talking to the wrong server here. If we have a look at the type 1 diabetes concept, you see this synonym here, T1DM hyphen type 1 diabetes. So that pattern occurs in a number of SNOMED synonyms across a whole range of places where there's basically an acronym followed by a hyphen followed by its sort of expansion. So Onto Server knows how to recognize that pattern, and it says, okay, this is the acronym for the abbreviation. I will score that specially. So it doesn't really create extra things. It just scores it specially so that its acronym matches that overlap with word prefixes are actually ranked higher than the raw word prefix.
That makes sense. I think we did. Did we get CT Cub added anyway, Trace? That was our particular issue, wasn't it? We got it added.
We did.
Yeah, we did.
I think it was CT Cub.
With
contrast was in SNOMED, but without contrast wasn't in SNOMED. So yeah, we got it added.
That's the other thing, is there's a lot of content like that in SNOMED where you'll get one concept that's got a whole lot of synonyms, including acronyms, and then another one which is very closely related, maybe the left and the right, or on one part of the body and then another part of the body. One's got this really rich set of synonyms and the other one's barely got more than a preferred term. So that can have an impact on searching. The other thing you'll find that you might want to do in a search field is something like diagnosis. There's a large number of things with the same prefix. So, if we're looking for hypercholesterolemia, there's lots of hypers, and many of them are not likely to be entered. So there's this concept of boosting, which is basically having a list of a set of more common concepts you'd have in a second value set. And then when you do your search, that shorter value set onto a server can score, give a higher ranking to. So you're still searching over the union of the two value sets, so the full set of, in this case, 100,000 clinical findings, but you've had client-side ability to re-rank or adjust the scoring of the search results. And you can adjust up or down, so you can push some down and push others up, depending on what your interface requirements are. But still get that simple behavior. And so it's still a single interface and makes it easy to find the common things. Then the last thing I wanted to talk about was the sort of dynamic interaction between different fields. And so here we have a procedure, and it's possibly lateralized. So maybe I'm doing excision of the lung excision, and this is a lateralizable concept, and so the laterality field is enabled, and I can choose one of the laterality options. But maybe I'm not doing that. I'm doing a nose excision, which is not lateralizable, and suddenly the laterality field is not enabled. How does the user interface know that? What's going on is that when I selected a code, there are a whole lot of additional requests going on to find out more information about what's happened. So if I do my excision of lung, and so you can see down the bottom there, this is the search request, expand, that found these results. And I select that. There's a set of additional requests that are being fired off. And what they're doing is they're doing things like looking to see whether this code actually already has a laterality in it. So this little bit of ECL, you can see at the end there, you see 119746007 dot, and then let's see if we can, here we go, this bit of ECL here. Sorry, this one. This is looking to see if there is a laterality already associated, or actually if there's a finding site associated with this a procedure site associated with this procedure, and also to see if there's a laterality associated with the procedure site, which is this longer ECL expression. So they're constructed on the fly. There's another bit of ECL there. And also looking to see whether or not this code is a member of the lateralizable or the body site that comes back from this, if there were any, to see whether that's a member of the lateralizable body structures reference set, say whether or not this can be enabled. So lung excision has a procedure site of lung, and then we're doing a membership test of lung in the lateralizable body structures value set. That could have been done with a validate code rather than an expand. And so that's how these two things are going together. The other thing is if we actually, we selected a concept that had lateralization already in it, these additional expands would extract the fact that this laterality is right and could be used to set this field directly. And if we, obviously, if we choose left, it's going to switch across to left. So this field is going to be tied to the concept. The behavior of this is tied to the concept selected here, with just a series of additional calls. Because these are all gets, they can be cached and the responsiveness can be really quick. A little bit conscious of time because I think we're getting to the end. So I just wanted to say a couple of things. All that code, so that's this SNOMED UI, is all open source and available again on GitHub. If I can find the chat, I can post a link in the chat.
I think Ward's already done it for us very kindly.
It's not the link to the source though. I think Michael has the source there. And the breakout room is going to end in 40 seconds.
Oh, what do you have to do? Do you have to, oh, it'll say, oh, you go back automatically, do you? You don't have to leave.
I think so.
I think you can leave, but it should push you into the other room. But when you go back into the room, you'll be on mute.
Very impressed.
Mm.